Let's consider the changes that take place when hydrogen chloride, HCl, is added to water. You will need to recognize space-filling models of HCl molecules, hydronium ions, H30+, chloride ions, Cl-, and water molecules, H2O. They are shown on the screen here. When HCl molecules dissolve in water, they react with water molecules to form hydronium ions and chloride ions. In this process, an H+ ion, often called a proton, is transferred from each HCl molecule to a water molecule. Now let's take a look at this reaction in solution. The reactants, HCl and H2O, have black outlines, and the products, H30+ and Cl- have red outlines. Because the reaction between HCl molecules and the H2O molecules is not reversible, the final solution contains only H30+ ions, Cl- ions, and water molecules. Because the HCl produces hydronium ions in solution, it is an acid, and because all of the HCl molecules form H30+ ions, it is a strong acid. The solution of HCl is called hydrochloric acid. Now let's consider the changes that take place when acetic acid, HC2H3O2, is added to water. You will need to recognize space-filling models of HC2H3O2 molecules, hydronium ions, H30+, acetate ions, C2H3O2-, and water molecules, H2O. They are shown on the screen here. In a change that is similar to the reaction between HCl and H2O, when HC2H3O2 molecules collide with H2O molecules, an H+ ion can be transferred from each HC2H3O2 molecule to an H2O molecule, forming a hydronium ion, H30+, and an acetate ion, C2H3O2-. Unlike the HCl-H2O reaction, the HC2H3O2-H2O reaction is reversible. When an acetate ion, C2H3O2-, collides with a hydronium ion, H30+, an H+ can be passed from the H30+ to the C2H3O2- to form HC2H3O2 and H2O. Now let's take a look at this reversible reaction in solution. The HC2H3O2 molecules have a green outline. The H2O molecules that change have black outlines, and the H30+ and C2H3O2- ions will have red outlines. Because the reversible reaction favors the uncharged HC2H3O2 molecules, for every 250 HC2H3O2 molecules added to water, there are about 249 HC2H3O2 molecules in the uncharged form, one C2H3O2- ion, and one H30+ ion. For every 250 HC2H3O2 molecules added to water, the solution contains about 249 HC2H3O2 molecules in the uncharged form, one C2H3O2- ion, and one H30+ ion. The relatively low concentration of the H30+ ions is the reason why acetic acid is classified as a weak acid. Hydrochloric acid is a strong acid because all of the HCl molecules added to water form H30+ and Cl- ions. For every 250 HCl molecules added to water, the solution contains about 250 Cl- ions and 250 H30+ ions.